Hello, this is Charlie, and this is the soil water budget concept. In the soil water budget, precipitation, rainfall, fog, snow, is going to be the input, and the output is going to be evaporation off of the ground and transpiration, which is water that's used by plants. So the output is going to be evaporation and transpiration. So I got to talk about evapotranspiration for a minute. There's two things that we're going to look at. There's the actual evapotranspiration, which is water loss from evaporation of water into the atmosphere, and transpiration from plants. The combination of both of those we call evapotranspiration. So basically it's all the water leaving the system. Actual evapotranspiration is the actual amount of water that gets used. That's why it's called actual evapotranspiration, although we'll just abbreviate it as ACTET. So ACTET refers to the actual amount of water that gets used. POTET is potential evapotranspiration. It's the amount of water that would get used if you had an unlimited supply of water. So I think of it really as representing energy available to use water. So your demand is going to be POTET. POTET is how much energy to use water there is. So this is a map of precip, and for the test, I will always give you the precip values. I just very quickly want to go over Pacific Northwest has very high values. The Southeast has very high values. The East Coast has higher values than the West in general. And the Southwest has the lowest values for rainfall of any place in the U.S. POTET, this is a map of POTET, potential evapotranspiration, although really what it is just a map of temperature. If you look at the patterns that create temperature, if you look at the factors that create temperature patterns, we've got latitude across the plain states. The highest POTET values are in the south, the lowest values are in the north. So it's a combination of latitude and then altitude. For example, here we've got the Appalachian Mountains. They're high elevation, so they're cool. We've got parts of the Rockies over here. You can see the Sierra Nevada. Remember, it's high to be cool, so high locations that are high in elevation will have lower POTET values than other locations at the same latitude. But generally the pattern, you can see the highest values down here. In fact, if you went up from Texas straight up to Canada, the POTET values would just keep getting lower and lower and lower. And so what we're going to look at is the relationship of precip and POTET. So in the book, here is the soil water budget. We've got the supply, rain, and snow. That's water coming in. Here we have POTET. That's how much water the system needs. We have ACTET, which is how much the system actually was able to use. We have deficit, which is water that you needed that you didn't have. Moisture savings, there's two things we're going to look at with the moisture savings. Number one, we're going to look at how much water is actually in the soil, and then two, we're going to look at the change to that water. So if you had a month where you got more rain than you needed, some of that would soak into the soil, and you'd have a positive change for your soil moisture from last month to this month. On the other hand, if it rained last month but it didn't rain this month, then the change to the soil moisture would be negative because the plants would be using water from the soil. The soil water would evaporate from the soil, so you'd get evapotranspiration from the soil, so the amount of water in the soil would decrease. And then the third or last thing is moisture over. This is surplus in the equation. This is going to be surplus. Surplus is water that you have left over after you've met the needs of POTET and after you've recharged the soil. So only after you've met the needs of POTET and only after you've recharged the soil so that the amount of water in the soil is the maximum, anything extra is going to be surplus. But you can't have surplus until the soil is full. If you think of watering a house plant, it's exactly the way it works. If you water a house plant, you put a little bit of water on, the soil's going to soak it up. If you keep watering, eventually the soil is going to get saturated and you'll have water running off, and that's going to be the surplus. So now with the terms placed on top of the diagram in the book, we've got precip. Precip equals ACTET. ACTET equals POTET minus deficit. plus surplus plus or minus the change to soil moisture storage. Here we have the soil water budget equation. Precip, again, is the supply. Potet is how much you need. Actet is how much you actually used. Deficit is water that you needed that you didn't have. Storage represents a second supply, although ultimately all of the supply for this is coming from rain. With the soil moisture storage, to meet the needs of potet, you need to both look at precip and also soil moisture storage, and the combination of both of those are available to meet the needs of potet. And then again, surplus. Surplus is water left over after the soil is recharged with water and after potet, the needs of potet are met. So I know it's kind of complicated, but I think if we go through it, let's do a practice example. And for this one, in fact, for the next set of examples that I'm going to show you, all the numbers in red are the numbers that I will have to give you on the test. So you don't need to ever worry about how to figure out what the precip is, how to figure out what the potet is, and then to figure out what the storage. So for precip, I'll have to tell you that. I'll have to tell you potet, and I'll have to tell you how much water is in the soil, in this case 2 inches, and what the maximum is, 4 inches. So let's see how this works with Berkeley, California. The precip is 4 inches, the potet is 6 inches. We have a total of 6 inches of water. We have 4 inches in precip, and we have 2 inches in storage. So we're not going to have a deficit. Actet is going to be 6 inches. Potet is, we've got enough energy to use 6 inches of water, and between precip and storage, we have 2 inches of water. So actet's going to be 6. 6 minus 0 equals 6. So potet minus deficit equals actet. There's no surplus because we don't have any water left over. And even if we did, in the soil, there's no water in the soil. We've totally used up all the water in the soil. So we'd need at least 4 inches, more than 4 inches of rain in order to have any surplus. So in this case, if we had 5 inches of precip, then we'd have an inch still in the ground. That would be a fun exercise for you. How many inches of rain would you have needed to get in this example to actually have surplus? So in the case of Berkeley, we had exactly the right amount of water. We had just enough water, 4 inches of precip, 2 inches in the ground. Potet was 6, so there's no surplus, and there's also nothing left in the ground. Let's go over some rules of thumb that'll help you calculate these. Number 1, actet can't be more than potet. Potet represents energy to use water. So if you have enough energy to use 4 inches of water, but you have 6 inches of water, only 4 inches of water are going to get used because that's all the energy that exists to use water. If you have a deficit, you can't have a surplus. If there's a deficit, that means that you ran out of water. There was more energy to use water than you had water. Therefore, you've probably used up all the water in the soil, so there's no way that you've then filled up the soil to the point that it's overflowing with water. So if you have a deficit, you can't have a surplus. Let's take a look at Seattle. Seattle has a very different water balance. There's 5 inches of precip, 3 inches of potet, there's 2 inches of water in the ground, and the ground has a maximum storage of 4 inches. So because the precip is greater than or equal to the potet, that tells us that actet is going to equal potet. So we need 3 inches of water, we have 5, so actet's going to be 3, which means that there's no deficit. 3 minus 0 is 3. Potet minus deficit equals actet. So that leaves us with 2 inches of water. Those 2 inches of water are going to go into the ground. So the change is up 2 inches. Now there's 4 inches in the ground, and there's no surplus. If we had another inch of water, another inch of rain, then we could have had a surplus, but we don't. Phoenix. Let's take a look at Phoenix. Phoenix in the summertime has 1 inch of precip. They get monsoonal rain in the summertime. Big thunderclouds come. 9 inches of potet. There's nothing in the soil because it's dry in Phoenix, Arizona. So you should have predicted that we're going to see a deficit. And the deficit's going to be 8. We know that because all the water we have access to is 1 inch. If actet is 1, 8 minus 9 equals 1. So we've got 1 inch of actet, no surplus, and there's going to be no change to the storage. It was 0 inches, it's still 0 inches, and now it's 0 inches, so no change there. I've put some practice problems online for you. Take a look at those. If you have any questions, please let me know. That's it. I hope you have a good spring break.